In this video, we're going to focus on our terrestrial planets. We're going to look at Mercury, Venus, and Mars, and see how it's similar to and different from our own planet Earth. Starting with the Sun and moving outwards in our solar system, our first planet is Mercury. This is the smallest planet that we have in our solar system, and it also revolves the fastest around our Sun. It takes the Earth 365 days to revolve around the Sun, but Mercury does it in only 88 days, less than 3 months' time. But while it revolves around the Sun very quickly, it rotates on its axis very slowly. And its rotation on its axis determines how long a day is. So here on Earth, our day is 24 hours long. Because Mercury rotates so slowly, a single day on Mercury lasts 176 days here on Earth. But it also resembles our moon in a lot of ways. It doesn't really have an atmosphere, so nothing's protecting the surface. It has very low reflectivity, so it doesn't reflect light very well. It has lots of features from volcanism, or at least past volcanism, and it's been hit by a lot of materials over time, leading to a really heavily cratered surface from all of those impacts. Our second planet is Venus. It's called the veiled planet because it has a really thick atmosphere. And the atmosphere of this planet is going to create a cloud layer that will not allow us to see what the surface of the planet looks like. Instead, we can only see the atmosphere that's made up of a bunch of sulfuric acid. Not a fun place. But when we look at the planet itself, it's going to orbit the Sun in 225 days. So again, faster than the Earth because it takes us 365 days, but it's a lot slower than Mercury. But one of the things that makes Venus so unique, other than its incredibly thick atmosphere, is that it rotates on its axis in the opposite direction of every other planet. Most planets rotate counterclockwise, but for some reason Venus rotates clockwise. But as it's rotating, it's doing it slower than the Earth. A single day on Venus is the length of 243 Earth days. You might have heard as Venus being called Earth's twin. We're similar in size, similar in rocks, and we both have atmospheres. But because Venus's atmosphere is so thick and dense, it has something called an extreme greenhouse gas effect. Here on Earth, less than 1% of our atmosphere is carbon dioxide. But on Venus, 97% of its atmosphere is carbon dioxide, which means that instead of having one blanket on its bed, it now has 97 blankets. It keeps Venus extremely hot. But there are a lot of similarities. Again, Venus is called Earth's twin because of the composition of all the rocks is very, very similar to Earth's. But another big difference between Venus and Earth is our magnetic fields. We do both have them, which is unique, but Earth has a strong magnetic field, whereas Venus has a very weak magnetic field. So this tells us that whatever's going on inside of these planets is happening very differently, leading to different magnetic fields. But just like we see on Earth that there are some absolutely gigantic volcanoes, along the surface of Venus, we see that there are more than 1,000 volcanoes that are larger than at least 10 to 15 miles wide. The third planet from the Sun is Earth, but considering we've spent 14 chapters studying the Earth, I'm going to skip right on to Mars, which is our fourth planet. And we call Mars the red planet due to its reddish hue. Mars is a lot smaller than the Earth. It's about half of our size. But it revolves around the Sun much slower than Earth because it's farther away from the Sun. So here we revolve around the Sun in 365 days on Earth, but in Mars it would take us 387 days to revolve around the Sun. And while Mars does have an atmosphere, it is an incredibly thin atmosphere. Basically, its atmosphere is about 1% as dense or as thick as Earth's is. So it has one, but it's not super protective. And the gases inside of Mars's atmosphere aren't super helpful for humans. About 95% of the gas inside of Mars' atmosphere is carbon dioxide, that greenhouse gas that can keep the planet warm. And then it has small amounts of nitrogen, oxygen, and water vapor, which are the actual gases that life, whether it's humans or plants, need to survive. So we talk a lot about going to Mars to live in the future, but the biggest challenge we're going to face is having an atmosphere that humans can survive in. The surface of Mars has some really cool features, though. Similar to our moon, most of the surface of Mars is covered in really heavily cratered highland areas. But because we have these highland areas of high elevation, if Mars actually had liquid water, it would be flowing north, flowing downwards from those high elevations, and it would form a vast ocean close to the North Pole. But what's interesting is within the last few years, we started looking at what's just underneath the surface of Mars by using specialized satellites. And we found that within 3 feet of the surface along Mars' pole, there is ice. So there is water on Mars, which is really cool. That is one of the major things we would need for life to exist there. But another important thing, or kind of cool thing about Mars, is that it has the largest volcanoes in our entire solar system. It has a volcano called Olympus Mons that is about 400 miles wide. It's the same size as the state of Arizona, and it's just one single shield volcano. But at present, we don't have liquid water on Mars' surface. We have water stored as a solid ice at the poles. So the main force of erosion on this planet is wind.